So yeah, today we're gonna spend probably like 5-10 minutes just going over the retreat feedback. Unless Vivian, did you get a chance to go over this during the code meeting?
No. Yeah, if I can
Okay.
have like five,
Yeah,
10 minutes,
yeah.
that's perfect.
Okay, yeah. So we'll start off with that. And then last week Vivian brought up some potential issue and like a solution to object distorting behaviors. I put the link to like her write-up in of Excalibur in the research channel. So yeah, we can join in on that when that happens. And then as time permits, I think the presentation will be short, but I already have questions that I came with mine. So depending on how that goes, that may be the main topic of today's research meeting. But as time permits, we can also continue on
I
to the
can't
Google
I
Drive.
can't imagine that topic's going to be short. It's, it's like
Yeah,
it is very confusing. I don't think we understand it very well. At least I don't.
yeah.
So I
Oh,
can't
actually,
imagine.
yeah, yeah. Now that you say that, if you could also go over like what problem it's trying to solve and the distortion model, like just introducing that concept again, that might be helpful to, I guess, Tristan who might watch this later, and also probably everybody who's watching this on YouTube. So,
Yeah, I
all right.
updated the Excalibur board this morning to kind of add a bit of context first again to recap a little bit the problem, but mostly the kind of what I presented on Friday of the brainstorming week. All right, so this was a bit of a recap, but I thought it might be useful to give some context. So basically, well, where we started out was that we had a solution to modeling object behaviors, or we have a solution to modeling object behaviors. We also had a really nice idea for how we can use an object behavior and apply it to make predictions about morphology. That was that idea of using kind of the movement stored in the behavior model and sending them to the child column to move you through that reference frame, the same way you use the sensor movement to move through the reference frame. And I still think that's a really nice idea. But one issue with that idea was that it didn't work with object distortions or behaviors where a lot of parts on the objects move in different directions, like not the entire child object moves together, but yeah, all the parts on the child object or all the parts on the object move kind of separately. And so I kind of call that object distortions generally. And so when I kind of restarted thinking about it, I thought about just object distortions in the static case first. So no behaviors right now, basically just thinking about what are all the ways we can recognize this cup? How can it have all the different distortions? So we might have a model of a coffee mug, and we can recognize that coffee mug again. We can recognize it in a different orientation or location in the world, and we can recognize it in a different scale. And all of that is already taken into account by our theory. We can also imagine a scale in one direction where we just scale the movement vector by something in only the x direction or something. But then you can also have these more funky distortions like different scale at some locations or different scale and orientation at different locations on the model. Um, so basically different transformations that would need to be applied to the movement vector depending on where you are on the object. And for these object deformations, we kind of have a solution proposed already, which is the idea of I should have put a picture of that in here, but like the bent logo on the cup, where you have the logo and then at some point it turns its orientation and bends, and we put that on the cup. And the way we learn that is that we use hierarchy and we learn the child object location, orientation, and scale on a location by location basis. So it's not like the child object has one orientation, location, and scale, but it's associated at different location on the parent objects, it can have different orientations or different scales. And this is just a sketch, but hopefully it's kind of simple enough to follow. Basically, we would have the Numenta logo or TBP logo being modeled down here, and then we would send its object ID up to the parent column. So the parent column could model the cup, and on different locations on the cup, we would assign the logo ID, but we would also calculate the relative orientation of the logo to the cup and store that as well in the parent model. And that relative orientation can be different at different locations on the parent model. That makes sense so far? Okay. So then I kind of extrapolated a bit on that idea. So one thought was the map of the translations, orientations, and scale could be independent of the specific object. So instead of saying we have a relative orientation of the logo to the parent and that relative orientation is different on different locations, we could have that map independent of the logo on cup parent object. It could just be a general deformation model that kind of models relative orientations at locations, and you can apply that same deformation to different objects to basically then say, oh, now I have this different logo that bends. And you can imagine that immediately without ever having learned that different logo in the bend variation. And then instead of associating object-specific locations with each other in the backward connections, we would apply a movement command to the morphology's reference frame. So that's kind of a requirement if we would want to learn these general deformation models. We couldn't use the feedback connections that associates a location in the parent model with a location in the child object, because those locations are unique to the specific objects. We would need a more general solution that we can apply to any object. So we could use this mechanism that we talked about or came up with a couple of weeks ago, where we just apply a movement command to the child object's reference frame instead. And that is general, independent of the location, specific location SDRs.
I don't know if you want to start having a discussion yet.
Sure. Yeah.
Okay.
Yeah.
So I just on this last point, I was thinking about the bent logo, and oh yeah, I can apply it to another object. And I was trying to imagine, okay, I could imagine that. I could show you a cup with the bent 1,000 Brains logo. And I said, okay, we're going to put another logo on there. I can imagine that, but I wouldn't be able to necessarily make specific predictions about exactly where the bend occurred, right? It would be like, I wouldn't be certain. I would have to think about it a lot to say, oh, yeah, maybe how far across the 1,000 Brains logo did the bend occur, and then try to imagine how far across the other. It wouldn't be something I could just easily do. And it seems like when I learn it on the first time, I learn on a specific logo, I actually notice exactly where it occurs. Oh, it occurred right here between the U and the S or something like that. And so I kind of learn that. So my thinking here is that it may be too much to, instead of throwing away that particular solution, the one we have already, and throwing away because it's hard to make a specific prediction for a novel logo, I'm not sure that's a sufficient reason to look for an alternate solution in that particular case, because it could be that, yeah, I get the general idea of I'm a bend the image here, but I won't be able to make specific predictions about it. And it feels like, it really does feel like when I learn the original bent logo, I'm not sort of imagining some movements. I'm just, or behavior. It's just like, oh, I just look at where exactly on the logo the thing is bending. And that's where I learn those points. So I guess I'm not convinced that this particular example requires an alternate solution. I guess that's what I'm trying to say.
Yeah, I guess just to clarify, I wasn't thinking of this as like throwing away the previous idea. It was more like generalizing the current mechanism. So we would still calculate the relative orientation of the parent to the child and still send that information up here and still invoke mini columns and learn that the difference would be that those relative orientations would be in a different reference frame than the reference frame of the TBP cup with logo model. So it would be like a separate map, kind of like the behavior
Right,
model
right.
is in a
Okay,
different.
that's fine. But
in
then the idea
morphology
that
model.
we might imply the movement commands is weird to me. That's the part that struck me as like, hey, that doesn't seem like I do that. Maybe I didn't understand it correctly, but I don't see why I need to think about
Yeah.
movement commands in this particular example.
Yeah, I guess it just seems like a big ask to always have to learn the backward connection between the specific locations on every object.
Obviously I
Like,
couldn't, right? I couldn't learn the backwards connection.
yeah,
I could learn, it seems to me I could learn, so the backwards connections are tying it to a specific location on a specific child object. So let's say I can't learn that. Maybe I just don't have
Yeah.
that. Couldn't I still calculate the relative orientation at those points? And so I say, whatever is going on there, it's going to change orientation. Couldn't
well,
I do that?
so let me just put the backwards arrow on here so we know what we're talking about. But
It's that green one there, right? We just add that.
so basically oops, this is a very thick line. So this would be the backward connection. It goes up here and then
Right.
spreads, and we
Right.
have the activation here in layer 6A of the
Right.
location in the child object and the location in the parent object.
So
And
right. So I'm saying, look, that's not, we haven't learned that. We can't rely on it, right?
yeah, exactly.
But we can still calculate, or could we still calculate the relative orientation change at that point? Because that's not object specific.
Yeah, so we know the relative orientation in the parent column. And one thing we talked about using the layer 6 cortical connections, this is dark green
Yeah.
arrow, to communicate that to the child column. So yeah, I think that's still a valid general mechanism that would still apply
Right. So
in the solution I propose. I guess
right.
the thing that would require applying a movement command is if the location of the child object relative to the parent is changing. Because like if the logo bends, the features will also be at different locations now.
Well, so
So
imagine we just didn't learn the purple backwards connection. Well, we learned it in a specific case. We learned it with one object on the particular, the logo on the cup. And now we're going to see something else on the cup. So we would say, okay, well, this cup, I'm expecting the change in orientation at these locations, so that's going to be stored. I just won't be able to predict a specific object or specific location on that child object, right? So I guess it just feels like I can't do that. It's like I really don't have an ability to do that. I could sort of take a wild guess, but I don't have an ability to say, oh, this is where it bends, or this is what the stuff is on the left of the bend and the right of the bend. I have a general impression that the new logo bends someplace and sort of occupies the same space, right? I could say, oh, there's another logo about the same overall size here. So, it just feels like, it feels like, oh yeah, I don't have enough information to make a very specific prediction about where it bends. But I do know it bends, and that's all I can say about it. I could, I don't know specifically.
I have
yeah, I guess
do you want to go first? Okay.
I was just gonna say, I think I would say you can make pretty specific predictions. I think the example of the bend is like not knowing where exactly the bend is more because you don't know how to anchor the distortion yet. Like you don't know where like what's the location in the distortion reference frame yet before you actually see the bend in the logo. But if you think of a distortion that is more uniform, like let's say it's an arc-shaped logo, there isn't like a bend in one location, but it's just an arc. You can imagine applying an arc to any kind of logo out of the box without ever having to
Right.
learn these associations.
It's funny when you think about the arc, I also feel like, oh, I didn't learn that. It feels like I wouldn't know exactly which letters in the logo are at different points in the arc. Um, it's
I
sort
would
of,
know roughly,
Mhm.
right? I mean, I feel like I could make pretty good predictions.
Well, but you wouldn't know exactly. I mean, it's like I think about the old Intel logo, which had the dropped E, right? If you're familiar with that. And like you look at it and you go, oh, there it is. The E is dropped. You know, like, and from then on, I know exactly where the logo is supposed to change. It's where the E drops. And I think here too, like here, I might say, oh, look, like you just drew it between the U and the M. But I wouldn't know that specifically for another logo that might be there. In other words, I could guess, I could sort of try to imagine it, but I wouldn't know, I wouldn't have learned that specific point there.
Yeah, but
Uh,
that's what I think is about the anchoring. Like once you anchor it where where in the distortion reference frame you are, like once you see the bend, you know how to predict all of the letters after the bend.
Right. All right, I'll let you continue here. I'm gonna just lodge a point. I won't go as far as calling it an objection, but I'll call it, I don't like it, or it bothers me slightly.
Yeah.
Which is the idea that we're gonna somehow use these uh, movement commands to, which we came up with for behaviors, right? We came up with them for object behaviors.
Yeah.
And I'm still good with them for object behaviors. I think that's good. I'm just not comfortable applying that same mechanism now to a non-behaving deformation. And in the back of my mind, I can think of all these reasons why I don't like it. But we can keep going. I'm going to come back to it. I'm just saying, I'm not sitting here right today going, oh, that's a great solution. I'm thinking like, oh, I'm not so happy about
Yeah.
it.
Yeah, actually, so once I get to like, next, I was going to talk about the proposed solution, but then there's an issue with it. And for dealing with the issue, it actually goes further away from applying the movement command again. So
Yeah, I
maybe,
know. I was reading your stuff this morning. It's like you have to do this sort of a cumulative movement vector, right? Is that what you're
Oh.
referring to?
not, no,
All right,
but
well, I'll let you keep going.
yeah, Hojae, you wanted to say something, I think.
Yeah, I'll just make it real quick. Okay, I think I am on kind of the same boat as Jeff in terms of I I agree with both of you. Like for example, if we have the Numenta like Beds logo, oh sorry, kind of snaps in, and I want to predict the TP, like it could be like non-overlapping. I don't know why the T is not showing. You might need to refresh your screen on Zoom. I can see it just fine on my Saldra, but
Yes.
just for the sake of okay, I don't okay, but well, my T is gone, so I can just log your T. All right, so like this might be what we want to predict, but also, again, we don't know where we anchor, so it might be kind of like slightly overlapping. We kind of, rotate it at a different point. But again, like I just say, that's because we don't know where we're anchoring this kind of change. I think
If it's
may
overlapping like that, it wouldn't be the same distortion, I would say. That this is like a different type of distortion where the bend also includes a translation of the bended part towards the non-bent part.
I mean, if I'm, for example, um, like bending at like, oh, wow, this is really big. Like at this, yeah, I don't, yeah. But I think I'm what I'm trying to get at is the general deformation, is that more related to um so like I'm on Jeff's side of like I don't know if we can make like a prediction, like we can make
This
some
is
general like
this is a general
prediction.
deformation of my head. See, it's two generations.
Yeah.
Uh, your behavior suddenly has changed drastically.
Yeah. Yeah, so my sense is I'm not sure if we can make like swift prediction of where this B or P like might be, but maybe the more like uh I still want this general deformation model to be learned in the sense that we want to learn some general behaviors. Like if we see stapler hinge, like stapler opening, like we want to recognize this as a hinge behavior so that we can potentially apply this to a laptop and like realize that the laptop opening is also like a hingy behavior. Like, yeah, I'm not sure if it's like kind of related to that or not, but hello. Okay. I think okay, I
Well,
can see that my point is lost and maybe we
No, no,
should
I'm sorry. I
we
don't
can
want to
move on.
distract everyone, but this is
No, this
this
is
is what's
good.
going on. This is what's going on in my life these few weeks. All right, I'm going to dismiss them now.
And it's okay. Do you want to learn about object behaviors?
They can't
yeah,
hear.
well, they are, I'm sure, learning a lot about behaviors right now.
Lizzie's pointing at the screen, going, "Wow, look at all that stuff."
There's also a dog on the
Switching into
screen.
full grandparent mode.
Yes,
Okay.
full grandparent mode. Well, no, half grandparent mode. There's only two of the four.
It's a lot of people. Um, yeah, sorry, Hojae, do you want to just briefly
See that
Just
again.
brief
I
entertainment
think I
interlude
agree
there.
with
Okay, sorry.
everything but just to, yeah, rehash.
Yeah, I guess the more interesting question is can we recognize kind of similar behaviors across different objects is maybe what we're I'm not sure if that's ultimately what we're trying to get at, that stapler opening and the laptop opening is essentially the same behavior, and we want to recognize that as the same behavior. Um, and it's related
Yeah,
to this in the sense that, like, oh, if we learn the stapler behavior slash deformation, I guess it's not the same thing, that we can theoretically apply this to laptops. I think that it implies that we recognize this as the same behavior.
yeah, I guess how I was thinking, like why I was starting to go down this road is because to me, like object distortions seem kind of similar to object behaviors in the sense that they are independent of the specific object you're applying it to. Like you can imagine bending all kinds of objects, you can imagine breaking objects, you can imagine stretching objects. It's not dependent on like when you have a coffee cup, or maybe that's a bad example because it's not bendable, but if you have a balloon, you can imagine it inflating with all kinds of print on it. You can just imagine a logo on it inflating with the balloon. Um, and so it seems like that kind of distortion is similar to object behaviors, just a way that features can change their location, orientation, and scale, but it's
Mm.
independent of the specific features that are there and changing their location, orientation, and scale.
You know what it feels to
Yeah.
me like? It's like it's like in object behaviors, we definitely have this time flow, right? But it's more like when I'm looking at these distorted coffee mugs, it's more like a keyframe or a learned state of a behavior in some sense. And therefore I don't need to do the path integration of or the time integration over time of the behavior. It's more like, oh yeah, like when I look at all, if I look at like especially the bent, the one that the coffee cup's tilting over, or even any of those, it's sort of like I imagine them. Uh, uh, well, all right, it's different. Like the one on the right here is definitely, oh, that's not normal. I'm applying some kind of weird behavior that I've learned, some behavior or some distortion I've learned elsewhere that might be behavior related, and I'm applying it here. The middle one, no, that's that's a form of cup I see. I don't see that as a distorted cup. I would say that's a standard cup. I've seen those, and same the one on the left. So the one on the right feels more like a keyframe of a behavior, or the other two don't. They just, unless I see them.
But here, like the logo distorts with the cup, so like the cup
Yeah.
gets broader and the logo gets broader as well.
Right, but I would still just learn that. I would still think of that as, okay, that's just our standard compositional model.
Yeah, but I guess the point is if you then put a different logo on here, you would know how it would look like with the kind of scale getting larger towards the top of the logo.
It's all
I
very
think,
confusing. I'm sorry, I find this all very confusing. Because some of these feel like, oh yes, this is a deformation. And others are like, no, that's not a deformation. That's a, I've learned that maybe like the cup that has the middle one here that you're looking at, regardless of, it just looks like, oh, that's a flavor of cup I know. There's no way. I've seen lots of them like that, so I just accept it. I probably, if I saw a lot of cups that were bent like the one on the right, I would maybe look at that the same way. I say, oh yeah, that's a flavor I have. But the first time I see it, I might think like, oh no, that's like a bend. Somebody bent it somehow. I don't know. I guess I don't see clarity of I'm bringing up lack of clarity in my thinking about these things. I don't think they're all in the same class, or they're different points in learning. I don't think it's simple that these are all sort of flavors of the same thing.
well,
I can try
maybe
to
it's
explain.
my
Yeah.
drawing skills, because I was trying to make it really look like the cup is changing scale towards the top and everything on the cup is changing scale with it.
Well,
So
all right. In this case, the only thing that you would really indicate that would be the logo, right? And then that's just putting a distorted logo on a standard cup. Now, obviously, if I saw cups behave like this, if I saw them start cylindrical and then became conical, well, that would be a different thing. I'm still going back to my basic objection to or uncomfortableness of saying, oh, I'm going to solve these somehow these problems have to do with behaviors. Although the one on the right feels like it's more like a behavioral type of thing, like, oh, I've seen things bend before. So this looks like it bent. This looks like it's a result of a behavior. But even then, it looks more like a keyframe, and that's like, oh, I have to imagine what I have to imagine my movement commands have to get bent to follow this. You know what I'm saying? It doesn't feel like that to me.
yeah, I would describe the model more like a keyframe as well. So yeah.
Right, right. And then can I just throw something else? This is really confusing topic. So I've often thought about like, often we can take one two-dimensional object and wrap it around a three-dimensional object. So I can take, imagine our logo going across the top of a car from the left side to the right side, something like that, or a van. I can imagine that. So I have the morphology of the van, and I can take a very big logo and have it wrap around the top of it. I can do that with the face. It's just sort of a general property of applying one model onto the distorted, or not the distorted, but applying it to the image of another model. In the same way that we talked about the logo wrapping around the cylinder. Anyway, I'm expressing my confusion. I don't know if anyone else is finding this confusing, but and I'm not understanding what you're saying. I think I understand what you're saying, Vivian. My confusion is I'm just not happy with our description of it so far.
But I feel like the example of wrapping a logo around the car or just wrapping it around the cup is a good example of why we would need a general distortion model instead of having to learn that specific, like those specific associations for a specific logo and shape combination.
Well, I don't know if I think it was a distortion model. It's just I need the morphology of one object, and that's not a distortion. I mean, in some sense, I can take a two-dimensional object and wrap it around the morphology of a three-dimensional object.
Yeah.
Which it's not a distortion model. It's just I'm just applying it.
Yeah. So, but the problem with that is that to make predictions about the two-dimensional model, then we have to learn these explicit feedback connections between the locations on the morphology of the cup and the locations on the 2D logo. And then if we take a new logo where we haven't learned these feedback connections, it wouldn't work.
Well, again, I'm not sure it wouldn't work. What if R1, okay, R1 is some long skinny logo and R2 is the top of the minivan or the van, okay? And, or you could just stick to the cup, I guess. Well, first of all, R1 knows it's looking at the new logo, the new image. And so it's going to keep assuming that's the case. It says, I know that. So all it needs to know is like, so I don't have to, it doesn't have to be told that over and over again. It says, once you've recognized it, it says, yeah, I'm looking at the new logo. And then, so we don't need to pass the ID back. We just, the only thing we're going to struggle with is we have to pass back any kind of scale and orientation and specific location. And I argued earlier, you might not be able to know the specific location. You know, you could guess, but you wouldn't know specifically.
Like based on just the movements of the sensor, you would move in the 2D reference or in the 2D model of the logo, and those would be getting more and more off with the bend of the cup. So you make wrong predictions about the features you should be sensing at locations.
Well, I
If
think
you
you can't
have
make
a-
it. I think it's very difficult to make an accurate prediction. That's my point. So, you know, if I saw the Thousand Brains logo wrapped over the top of a car, and I'm looking at it, and in one image I'm looking at the side of the car. One image it changes. It bends between the O and the J in project, and another time he showed me bending between the N and the D in 1,000. I wouldn't know either one of those is wrong. I wouldn't say, oh, that's wrong. I wouldn't be able to predict that. I would say, oh, the logo is going around the top, and okay, that's where it breaks. You know, I wouldn't make a prediction where it's going to break. Unlike if I really had learned the object and learned a specific thing, I might learn where the prediction, where, you know, I would then. I guess I'm just saying, I don't know if we can predict that.
Yeah.
I think that's valid. Just so that I'm like understanding this correctly as well. Like the problem that we're trying to solve is we have this, you know, canonical cup, and then let me copy over the scaled one. That, you know, if we observe the behavior of, you know, I don't know, the logo like rotating, I guess, and we saw a different, like a deformed version of the cup, then without having to learn the rotation again, that we'll be able to predict, like if we have observed this behavior in the standard, that, you know, that we are assuming that we can predict what's going to happen if we apply that behavior, but just to a different morphology.
I thought the problem goes back prior to this. Maybe I'm wrong, or maybe my memory is bad. I haven't been thinking about this for a couple of weeks. But I thought it was more like we're trying to deal with basic deformations of objects. And, you know, the extreme versions like a t-shirt, there are in-between versions, maybe a flag waving, then even like the very simple one, I kept saying, you know, what's an egg versus a circle, right? And it was very fun. It was something along those lines. Is my memory incorrect about that? We were trying to say, hey, I have an object and now it's deformed somehow. Like an egg is a deformed circle or something like that.
Yeah, and I guess there are two parts to that. One is being able to recognize the object in its deformed state, which is kind of the static version of the problem. And then the one we started with was the deformation happening as part of a behavior that you learned. So like a ball bouncing and squishing, like the circle turning into an egg, or the balloon inflating, and you're kind of learning how you go through the deformations, or how the object is deforming over time.
Those seem to be sort of separate things. one is recognizing deformations of, non-moving deformed objects. And the other is saying, oh, being able to know the behavior of the object between sort of those key states, those keyframes. I
Yeah.
can imagine a ball and a squish ball, and I can imagine the ball bouncing. That's a behavior I've learned. But I can also imagine, a ball instantaneously turning into a squish ball, or a ball popping out like a cartoon into a cube or something. I don't know. I'm just saying I can imagine different behavior. Maybe I can imagine maybe I could put, I can imagine applying a lot of pressure to a sphere or a ball, and it doesn't collapse right away. It just moves a little bit, and then all of a sudden, boom, jumps down. So my point is the actual behavior between these two keyframes is not dictated. I'm just trying to, again, separate out the idea that I have two images of the same thing, and I don't always have to have the behavioral sequence between them.
Yeah.
They sort
Yeah,
of
I think
seem-
that's consistent with my proposal, that you would have kind of keyframes of distortions that let you make these kind of predictions about what to sense where. But then for the behavior model, you still have everything how we discussed it before, that it basically stores changes in time at locations, and you can recognize the behavior and predict.
Right. So all I'm saying is I feel uncomfortable with the idea that if we're not observing a behavior and we're just observing the distorted result, that we're going to use the mechanism for behaviors to help us out. They don't.
Yeah, so this is yeah, I'm not proposing
That's
that.
what
I
you
guess.
are. That's using the movement command.
Well, okay, yeah, the movement command is yeah, okay, I was thinking of that more as like a general mechanism we could use for different things, but um, not necessarily behavior specific. So, okay, if you mean that, then yeah, I did steal that mechanism to use it
Well,
here.
and maybe I thought it was a great idea when you first mentioned it. I don't know.
Yeah, maybe I'll go actually into what I'm
Yeah,
proposing, and
okay.
then we can talk
Right,
more
that sounds
keep
about
good.
it.
going.
Yeah.
Keep
Yeah,
going.
sorry.
Sorry.
Go ahead.
So I'll try to keep that brief, if that's possible. So yeah, how this relates to object behaviors. Object behaviors can distort the object, like the balloon. As the behavior is distorting the object, we want to continue to make correct predictions about the morphology. So we want to be able to move somewhere else on the balloon and know what to expect at that location. Proposal, could we learn both a stepwise and a distortion map of an object? Maybe yeah, okay. So basically, I think we walked through this last time as well. The stepwise one is the basic behavior model as we talked about it for the past months, storing changes at locations over time. It's used to recognize a behavior and to predict changes to observe next. The cumulative one would be a separate thing. It would be kind of what I'm talking about as the distortion model. So it would store the difference between the original morphology of the object and the current time step, or just generally between the original morphology and a distorted version of the object. This one doesn't actually represent anything in time, but I was thinking of it as you could learn an association between a point in time in a behavior sequence and such a model. So I would call this a deformation model, which can be used to make correct predictions about morphology after the deforming behavior has happened. It can also generally be used to recognize deformed objects and make predictions about them without learning a new model. So it would be it wouldn't represent anything with time. It wouldn't be the same as the behavior model, but we could associate this with a point in the sequence and be like, all right, if we went through this behavioral sequence, now we expect whatever object we have to be in this distorted state. And so if we want to keep making correct predictions about the features of this object, we have to apply these distortions to our existing model. And so basically what we would store in this distortion map is, if we are on a location, Oh, there's no red dot, you know. I copy pasted this from the other whiteboard. So if we are on a location in the object's reference frame, we need to apply the inverse of what's stored here to the incoming movement vector. Or it would be, this is confusing now without the red dot, but basically it means given any morphology model, what kind of transformation do I need to apply to get from the current location in that object's reference frame that's based on how my sensor moved to the correct location where the feature is stored that I want to invoke. So let's say I have a model of the balloon. It has all these features stored of like a logo that's on there. But now since it inflated, those features are at new locations now. And the deformation map would basically tell us how these new locations map onto the original locations in our model that we learned. So maybe I'll do this example here. Let's say we have the Thousand Brains Project logo and it distorted, so the logo mark moved to the left, the 1000 moved up, and Brains Project kind of rotated and fell down a bit. And so this would be the distortion map for it. It would basically tell you, like, if you're here on the logo, the feature you would be expecting is actually down here in your model, assuming this is the model that you learned. So then let's say I'm moving my sensor from the T down to the P here. We'd apply that movement in the distortions reference frame, distortion maps reference frame. From here to here, we would have this kind of compensating transformation stored there and apply that to the movement. And that would then tell us where in the object's reference frame we would expect to be. So that would be the P. So it would tell us, all right, now we expect to be here on the logo, and that means we expect to sense the P. And that works independent of where you're coming from or how you're moving. So another example, if we have this kind of bending cup, let's say first the red movement. So some of these errors have changed since I copied this. So basically we're moving from here up to here. We apply exactly that movement of the sensor to the reference frame of the distortion model, like this. At the location in the distortion model, we have stored kind of a compensating movement. We add that in, and then this resulting vector tells us where we would expect to be on our original model of the cup. And then as another example, if we do the screen movement, we are at the bottom of the handle. And we're moving again to the edge of the cup. So let's say we're here. We would also apply that to the reference frame of the distortion model, add this orange arrow to it that's stored there, and that would tell us the correct movement in our model's reference frame. So in summary, this idea would make use of the idea to apply movement transformations in addition to the incoming movement vector from the sensor. Would apply translation and rotation so that the feature location on the deformed model corresponds to the location of the same feature on the non-deformed model. And the stored post transformation, so what's stored in here, would have to be absolute differences between the current time step or the current deformed state and the default model that we have learned. If this is within a behavior, I think it would be probably too much to ask to calculate this on the fly. So I was thinking of it more as like keyframes that we store that are independent of a specific object. And these distortion keyframes could also be used to recognize distorted objects independent of like what behavioral sequence led up to it, or if there was even any behavior that led up to it that we observed. And they would reduce the need for storing morphological states specific to objects. So if we would have this solution, we don't have to learn keyframes of specific objects anymore, like we had discussed before.
So I have a question.
Yeah.
When thinking of a single column, how does a single column know how to integrate distortions in other places of like at different locations if it can only observe one location on that behavior? Like it would need to know the full behavior to know how to, like, how does it come up with this cumulative map of distortions everywhere? And we're only just thinking of a single column.
Oh, so this map, it would take a long time to learn this. So like you wouldn't observe everything at once. This would be, yeah, like learning a cup. You have to observe all of these locations as they are distorting. And then kind of one way I imagine this could be learned is that if you're doing smooth pursuit and tracking a feature as it moves, you kind of try to have a constancy that this feature keeps getting moved to, keeps getting mapped to the same location in the object's reference frame. Similar to how we discussed, maybe the thalamus learns that like as an object rotates, features should still be mapped to the same location as in the original object model, or like, yeah, basically preserving this feature constancy. But yeah, you would have to learn this over time, same as the behavior model, where you can't observe all the moving parts at once, but you kind of have to see it many times.
Would it maybe have
Um,
like template behaviors? Because my problem is I'm thinking of this as, you know, you observe a few features on the behavior and you're basically able to extrapolate what's going to happen on different parts by just predicting or assuming, you know, that, oh, I see, this is the scale behavior or this is that behavior. And then you can maybe say, okay, at this location, assuming that my behavior is correct, this is my prediction, this is what's going to happen. So I'm thinking, are these cumulative distortion maps maybe leading into if we cluster them somehow, or if we come up with a way to categorize them, that we can come up with template behaviors that we can apply and easily just infer and use? Or are they just like going to be a different distortion map for every behavior? And we just have to learn every single distortion on a map.
So those don't tell you anything about the behavior themselves. They just say how the features of a model remap to new locations and orientations. So like there's no temporal aspect to this. There's no sequence or anything. So I don't think it could replace or help with modeling object behaviors. It would replace storing keyframes for objects, for specific objects. But if I understand your question right, I don't think it could help with learning behaviors.
In my mind, they're still describing behaviors. I mean, um, like these distortions are basically another way of describing what behavior has happened, or is
Well,
about.
that was the point I was trying to make, Romy. It doesn't feel like that to me. I mean, and when I look at this, I don't feel like, oh, that's an object that's undergone some behavior necessarily. I mean, I do with the bent cup like this, but I don't do it with the conical cup.
Yeah, maybe
Yeah.
kind of like you do kind of get the feeling if you see this that you imagine it bending. At least I
Right,
do.
right,
But it might
right.
be because you associated this distortion with a behavioral sequence
Well,
of
oh, maybe because I've never seen, I mean, I've seen bent things, but I've never seen a bent cup like that. So again, as I was saying, you know, it's just because in this case, I just don't see cups like this, but I do see things that look bent like this. And so where the conical cup, what if I never saw a conical cup before? They're all cylindrical, but I have seen things that are made conical by, you know, some behavioral sequence or something. I might feel the same way about it. I guess I'm going to come back and lodge my general overall thoughts about this. This obviously seems like it would work when you thought through it, but I don't think it feels just somehow. I don't think we're getting at the essence of what's. I think just we're confused. I'm confused. I don't think this is quite capturing what's going on. it's hard for me to even put my finger on it right now, what it is, but it just feels like, no, I don't think this is right. It just feels something, there's too many odd things, too many corner cases, which, I don't know, it just feels like I'm struggling. I feel there's a simpler solution that's what it feels like. There's a simpler thing that goes on somehow that I don't understand yet. That's what it feels like. So that's not a very strong objection. I mean, it's strong in my mind, but it's not a very good argument. I don't, like, it doesn't
Yeah,
feel
I
right.
think maybe it feels a bit complex because it solves more than the original problem we set out to solve.
Well, maybe it's also, I mean, don't I have to learn these, what are we calling these
Distortion
these
maps.
distortion maps? Well, first, I'd have to have a lot of them, right? Because there could be a lot of different distortions.
Yeah,
Isn't that right?
yeah, that's right.
And then, so, gosh, how many distortion maps do I have? And,
But it would cut down on having to learn keyframes of objects.
but it seems like I do learn keyframes of objects, at least many of them. I mean, again, if I've never seen a cup like this, I would agree with you, like, oh, I have to somehow infer that this is not something I recognize right away. But it seems like the general case is, if I started seeing a bunch of cups like this, then I would say, oh yeah, I have a new model for that. The general case, we call them keyframes, or just, static models of some sort.
But
I'm not sure.
yeah, I mean, I don't know if we would need that many distortion models. Like it seems like we have models of very general distortions, but once you get to more complex stuff, like a crumpled t-shirt, we wouldn't have a specific model for that. Like you wouldn't have a model for every possible complex distortion. You would have models for like bending and scaling and
Right,
different.
but even bending, I'd have to have different ones at different points, at different amounts of bending, wouldn't I?
Yeah, but I
Yeah.
feel like that wouldn't be like too many models compared to how
I
many
don't know. I don't know.
object
It
models
feels,
you would have.
I don't know. It just doesn't feel quite right to me. It feels like, I don't have my put my finger on it. We made this transition once from thinking about object models as just being features at locations. And then we kind of made this sort of important but subtle extension of that, saying, no, it's really orientations at locations. And then we can assign specific features at those locations. But there's this morphological model which is independent of the specific feature. That was a huge leap conceptually to get to that. And I think it's held up pretty well, even if we haven't maybe worked out all the details of it, but I think it's held up pretty well. I feel like a similar sort of conceptual step is required here somehow. That, in the end, by the way, that idea that we have this morphological model didn't add any really new complexity to our biological circuit. It was just like, oh, we had mini columns represent orientation. We've always had mini columns. There's always, it fit. There was no real additional machinery to do that. Here I feel like, oh gosh, this feels like a lot of additional stuff, and I feel there's going to be a simpler answer to this. It's a gut feeling, so I'm just going to have to keep saying until I become comfortable one way or the other.
Yeah, I think that's a good point, that like if we have like a morphological model that's basically just orientations at locations for logo on cup, that doesn't tell us anything about the ID of the logo. So if we're storing that, like the child logo as at different locations and orientations on this parent cup, then if the ID of the logo, like there's suddenly a new logo on it, changes, that's not really changing which mini columns would get activated here.
Right.
So in that case, it would actually work quite well already. I think the thing that bothers me a bit is like the backwards connections of how we inform like where we would expect to be on the logo. And maybe that's just a case of we need to work a bit more through the details of that part. Maybe we don't need to add anything like distortion models, and this already works for it all, but at least to me, like making predictions about the child object, then if we have learned the parent on a location by location basis, is still not super clear.
Yeah, there's a lot of things that aren't clear to me. I'm still struggling. I keep going back to my egg and circle problem. And trying to say, does this inform me about that? Like, how do I even learn that basic morphology model? Is the egg a distorted circle or is it not? It feels like it isn't, but somehow, I don't know. I just feel it's messy enough and confusing enough and enough missing pieces that my intuition strongly says we're not there yet. There's something else. There's some conceptual idea that we're missing here. That's just how it feels to me.
Yeah.
It doesn't feel like it's a hard conceptual idea, just that we haven't thought of it yet. Once you think of it, it seems easy, but
I guess
Yeah.
I have a question about like how big these behavior models would have to be, and this is something I've been kind of thinking about in the back of my mind, and I've never brought it up, so I'm not sure if it's let's see if I can get over to where you are. If we had a simple situation like a stapler,
oh yeah, that's really simple. We spent
okay, I'm sorry.
6
Well,
months. We spent 6 months trying to understand the stapler.
simple in the sense that, this thing isn't like inflating while so it's just a rotating thing, right? Like, would we really need like a keyframe for every,
No,
because it seems
no.
like you could have something like a vector field that can apply anywhere throughout that sequence. It's just
Right,
one.
that is the behavioral sequence, right? Isn't that, Scott? Isn't that the behavioral sequence? That's the behavioral model. The behavioral model is that vector field.
Yeah, and it's like it only exists once. It's there isn't like
Right,
a
but
unique
then if the stapler stops, the basic theory we have right now is if the stapler stops, then you immediately start learning it as keyframe is the poor term, but as long as you all understand what we're meaning by it, we learn this is a different morphological state of the stapler. This touches a little bit back to what we were just talking about in Vivian's idea here, is when I see the open stapler, I don't go, oh, to predict what I'm going to see here, I have to imagine the flow through space. I don't have to do that. I've learned what an open stapler looks like, and that's that. That's what it looks like, So it's like you do learn this flow field, but then if it stops, you start learning a morphological keyframe if you want. I don't know. I'm sorry.
Okay.
Just reviewing what we've said doesn't mean it's right.
Yeah.
But so I think is your point that you think it's too much to learn? all
No,
that
no,
stuff?
not at all. I'm just thinking about sometimes we draw these behavior maps like they exist, like each one at each time point, it only relates to the locations that are currently in play on the
Oh, well,
stapler.
okay. Well, I guess that is right. If in some sense you've drawn all these vectors in one plane, but they wouldn't there be in one plane. They'd be in different slices of time. So maybe I jumped ahead there. So this isn't how we've been talking about it. We've been talking about each row of those arrows would be at a different point in time, but it's the same model though.
Right. So the way I've been kind of thinking about it is, well, can't we just, if we have the whole flow field, it can apply to any point in the sequence, so long as we like know which arrows to use based on like what there is matter at this location, for example. At this, I can't.
Well, let me throw a counterexample, which might throw a monkey wrench into that. Imagine the stapler goes halfway up, a quarter way down, and then all the way up again. So it doesn't make one smooth transition. It's like, if you can see my arm, it goes like,
True.
and that's
True.
its behavior. Now you can easily learn that, but now there are 2 points in time where the stapler is moving up in the same space, but there are different points in the sequence, right? At one point, I'm going to predict it's going to come down again. At another point, I'm going to pick it up again. But the flow field at that point is the same. The arm of the stapler is moving through space at this location, at this speed. But I have to have a unique representation otherwise I wouldn't be able to predict if it's going to go all the way up or if it's coming back down again. So that's
That
why
is true.
you can't have this flow field in one space like that. It has to go through time because the representation for each of those points is going to be unique. It's like a sequence, a melody sequence where you have the repeating notes. You gotta
So
have.
what if they're conjoined in some way? Because like let's say I am just playing with a stapler, so I'm not passively observing this example where
Okay.
where it goes like this, and then it's got there's like a hysteresis problem you need to remember.
It's not history. It's a unique point in time problem.
So let's say you're playing with the stapler, you're learning the
Okay.
stapler.
All right. I was describing a stapler that had behavior on its own, right? So that's it wasn't like I'm doing it. The stapler has this behavior on its own. But okay, but now we're not doing that. Now we're playing with the stapler.
Yeah, so I'm just thinking I'm learning what just sort of the basic morphological rules of this hinge. So
But
anytime,
even then, would at any point in time, then the hinge could go up and could go down, right?
yeah,
So you don't know which way it's going to go.
I don't, but let's just say this is reversible, like the arrows are reversible. Like if we want to move the stapler down, we just flip the arrow, order of the arrows or something. But either way, I can learn this flow field by just two successive neighboring observations. So if it's here and then it's here in the next minute, I've just learned a little part of that flow field. So I can sort of build this vector field of possible motions. And that's a compact representation of the whole, all the
Yeah,
morphology.
but I've just poked a few holes in this guy.
I'm wondering if let's say that was in the base, that's sort of the base model, but we could apply a second layer on top of it to add in particular cases of how you might move through that case, might move through those trajectories. Something that's like more compact than having to store like a behavioral keyframe that's unique to every point in the sequence.
Oh, that's right. This here.
You might even learn a sequence of not being able to hope this isn't sidetracking too much, but it seemed like it might tie into talking about how dense our behavior models have to be. But
Right. So we can't have them be
sequence,
too dense, right? Obviously.
yeah.
Or we can't have too many points.
So this could be the base behavioral model that it's very parsimonious. It doesn't require much, and you
Well,
learn
all right.
through interaction. But
let's
afterwards,
I think for starters, we're
Mhm.
mixing two things here, and we have to be just careful that we're not mixing two things.
Okay.
When I've been talking about up to now, when we're talking about the behavior of the stapler, always in my back of my mind, it's like the stapler is doing it on its own. It has its own behavior. That is, we're not interacting with it. It's going through some behavioral sequence on its own.
Mhm.
And that's quite different than an object that can move that doesn't do anything on its own, and I move it up and down. Those are really very different things. And so we have to be careful. We have to solve both of those, right?
Yeah.
And maybe we have, up to now, even though when we actually operate a stapler, we have to use our hands to do it. That's not how we've been thinking about it as an example. I don't know about other people. I've been thinking about it sort of automatically does its thing on its own, and we're just observing it. So if I have to interact with it, then we're getting into the sort of, maybe we should start thinking about that, because we have to do that. Real staplers don't move on their own. At least most of them don't.
Yeah.
And that's a different problem, or maybe it's a related problem. I don't know.
Right. I think that's sort of goes under the actions in our actions and maybe causality and the model logic behaviors. And I think that's another big topic that we need to have come back to, either like in a future research meeting or in a focus thing. I'm kind of curious if Vivian can go over the issues that, because I think I understood the model object behavior. We went over this, and I understand how this could work, but now I'm kind of curious like what the issue that she thought she saw was.
Yeah, yeah, I'd be happy to go over that. I guess only if Jeff, you think it's already too complex, then talking
Well,
about the issue will not help, probably.
maybe
But,
Well,
you'll make my
yeah.
case for me then, huh?
Yeah, I mean, I think the
Well,
mechanism itself is very clear. I guess I think where it's kind of unclear is like kind of do we need this kind of it's more of that sense instead of like okay, like I can understand like the composition of movement vectors to kind of predict what feature to expect. Yeah, so
Right.
close,
Well, right.
feel free to
I
go
think
ahead.
a good suggestion, Jose. Let's hear Vivian's issue.
Yeah.
okay, I'll try to be brief and then we can see if it's anything we need to go down deeper on. So as I was kind of thinking through this some more, I realized that all of the examples I gave and played through only did one movement, and that the whole thing doesn't work anymore if you then do a second movement and a third and a fourth movement, because the distortions
What
would
do you
then,
mean, like the exploding logo? Is that what you mean? Or what do you mean second movement, third movement?
oh, like the sensor is moving several times over
Oh, I
the
see.
so like, okay, so let me just show you. So here's again the example. We're on the T and we're moving down to the P. And so we go to the distortion map, we move here, we retrieve the distortion and apply that. In addition, so then we correctly moved in the object's reference frame, we correctly predict the P. Now we do a second movement. So we are at the P and then we move to the N. So now in the behaviors reference frame, we're here, we're moving up, we retrieve this vector here, add that vector, and now you just look at the red one. If we now add that vector, we're overshooting. We're up here now, because the location in our object's reference frame has already been compensated by the previous distortion, and now we're kind of adding up distortions over time. So what we would basically need to do is we still move with the actual movement vector that our sensor is doing in the object's reference frame. So the green one here, we use this green vector. We are at this location, and then we apply the transform that's stored to retrieve the correct feature, which is the N. So this is the vector we apply, which is the green one, but we apply it from this location instead of this location. So
That's a little weird
yeah,
because
so basically what we would need to do is when we move through the object's reference frame, we still use the correct movement of the sensor. We don't apply anything directly to the sensor movement, but instead at every time step, we take the location that we're at, given the sensor movement, and temporarily retrieve a feature at a different location, but we're not actually updating our location in the reference frame. We're just retrieving a feature at a different location when we make a prediction. So yeah, let me just read this out. So we keep track of the stored location in the object's reference frame and apply the movement to that every time. We use the actual movement vectors in the object's reference frame here, which is the green part, but invoke features stored at the offset locations. I'm not sure how practical this is. The compensating movement would not be treated the same way as the sensed movement. It would just be applied temporarily to retrieve the correct features, but not used for path integration over time.
So would another solution be to reset the cumulative distortion map every time we make a movement and then start building a new one?
I feel like
because yeah, that would get into a lot of other problems, and like then the distortions would be different and different locations. We'd have to learn a bunch of different distortion maps depending on how we move through the space. I think just temporary, like basically just using the distortions to retrieve a different feature would be the easiest way to solve it. So we only store one distortion map and we can use that, and we can move arbitrarily through that space, but we still retrieve the correct features. If I
I
understand.
feel
what
the
you-
memory replay, I mean, if we need to kind of like reset the cumulative thing, then I think just, going through the sequence of behaviors through memory replay is easier.
No, we
Um,
don't have to reset this at all. Basically, we move through the object's reference frame just using the movement of the sensor, the same way we did before. Nothing
Mhm.
changed. We are not applying any extra movement commands from the distortion map. We're just moving through the object's reference frame. But then when
Yeah.
it comes to predicting which feature we're going to sense at that location, we would need to take so we're moving through the object's reference frame and through the distortion reference frame at the same time. So both the green and like both this the movements through both those reference frames are in sync. Same thing happening here and here.
Yeah.
So in both of them we are at this location now. We retrieve the compensating thing, but that's not applied to change our location in the object's reference frame. It's just used to tell us which feature we should expect. So it just retrieves a feature at a different location.
So it seems
How
like
to
this one,
explain it?
yeah. Is this one like combining? So when we do two steps in the sensor, like one movement and another movement, we instead of doing movement, compensate, which will lead to in the incorrect prediction of the features, add up the movements of the sensors first, and then wherever it ends up, we apply that one offset at that location. Like so like this, yeah. If I say this movement is A and this movement is B, I'm just gonna label everything. Okay, so C and D.
Yeah, you
Before we were doing A plus C and then do a B and then D, but now we're doing basic. It looks like we're doing just adding up the movements first and then doing like a offset.
Yeah, that would work too, but I feel like that's more complicated than what I'm proposing. Like you would have to keep track of the movements, you would have to replay them after every next
Right.
movement. So that would involve a lot more than basically just temporarily applying these. Yeah, I mean, you're definitely right. That would work as well. It would make the correct predictions if we do that. But yeah, to me it just seemed a bit more difficult.
Okay. I thought it was this solution, so I'm not understanding your solution properly. Okay, I'm gonna try to read again, but you can but you can continue explaining. I thought this was your solution, which I was like, okay, I think this is the same thing as replay, or yeah. So let
No,
me understand it
in
again.
my solution, it comes out to whatever calculation this would come out to, but we're not replaying. We're just keeping track of the location in the object's reference frame, same as we always do. So A plus B is basically moving us from here to here to here. But as we make the second movement, we don't have to repeat the first movement. We're already here in the object's reference frame, so we just apply the next movement to know the next location.
Okay. Okay.
But
Okay.
do you have to, does it require looking up a second location for the features stored at the offset locations? I'm confused. I'm just wondering
Yeah,
how.
so basically, I think what you wrote out here, Hojae, is very helpful to explain this better. So what I'm describing as temporarily applying the offset is basically not applying plus C in between in the sequence, but instead, as we do the first movement, we do A plus C and make a prediction. But only the A is persistent in our location in the object's reference frame. So we stay at this location, which is off the object in the reference frame. We make the correct.
But I'm just trying to understand, is there two, you have to look up two things and do you have to keep track of 2 points in the reference frame to make this? Where you currently are in some other object, that's stored in location or something like that?
Well, yeah, so you have to keep track of your location in the object's reference frame. And then you have to apply the offset to make a prediction about the feature, but you don't have to keep track of the offset. It's just at this time step. Like
Yeah.
you don't have
So,
to keep track of it.
but it then there's two reference frames, one for the displacements or something like that. mean,
Well, there's
I'm-
these two reference frames. There's the reference frame of the
Yeah,
distortion
well,
model and
but that's a problem in its own right, isn't it? I mean, we're asking columns to have a lot of reference frames. Like,
yeah,
keep
yeah, that's
track of-
actually my main concern with this is that now we have 3 reference frames and
Yeah, I'm
that's a
beginning,
bit
I was worried
much.
of just having 2,
Yeah,
now 3. It just
yeah,
seems too much to ask. Or it seems unlikely. It's not impossible, but it seems unlikely.
right. Yeah, so basically, just to wrap it up, this is the last part I have, but mapping it on a cortical column, there would be 2 reference frames plus the behavior reference frame, which I'm not
Right.
showing because it's kind
Right.
of independent of it. We would have the distortion model and the object model, separate reference frames. The distortion model would store like transformations that need to be applied, like orientation changes or location changes. And a location in that reference frame will be associated with a specific transformation. And then we would have to apply that transformation to the location in the object's reference frame to retrieve a different feature.
Yeah.
So in our example, our location in that reference frame would be here, and that's what we would keep for the next time step. But the feature stored there is, in this case, nothing because the logo doesn't exist there. We apply this kind of offset that we stored in this model temporarily to retrieve whatever is stored at this location, which is the P. And then we move again, but the next movement will be applied starting from this location.
I mean, in theory, neurons could do things like this. It's asking a lot of them, but it could potentially, like, I have to like look up an offset in one set of mini columns or something, and then apply that offset to the location in another one. But when I think about like grid cells, I have no idea how you would do that. I mean, it's like,
Yeah,
it seems complicated. Again, we could implement it this way. I'm sure the software, you guys could make this work in software.
yeah. In software, I think it would be pretty straightforward. But I agree. I don't know how this would be done with grid cells. To be honest. And I guess maybe just as a side note, I showed in one column, but maybe some problems would be simplified if we do this hierarchically, where the distortion model is in the parent column, and then we can do some kind of
Yeah.
transforms in the thalamus. But I'm not sure if I wrote, I'm not sure if this would solve any problems, just to throw out that possibility if you think this
Right.
would solve any problems.
So again, I'm always worried that, oh, well, this would work, we could implement it. But I'm always worried that it has consequences down the road. So that we like it's just
Yeah.
digging a hole and we're gonna have trouble getting out of it in the future because it's going to try to make it work for the next thing and the next thing. So I'm gonna say it again. I think this is a great proposal, great to make us think about the problem. But I'm not on board on the solution yet. I feel like we're missing some things or a conceptual, just thinking, it's more like we're not thinking about the problem correctly, not that the solution isn't correct. It's more like we're not quite grasping the entirety of the problem yet. And this problem is really broad, right? We start off with object models, and we split into morphological components and then the specific features. Then we did compositions, and then we did distorted compositions, and then now we have behaviors. There's all these, and then I'm still worrying about the egg and the circle, and um, uh, and now we have these deformations. I mean, all these things have to be solved. I just feel like, oh, it's something we're missing here. It's just it's not all. It doesn't feel like, oh, this wraps it all up for me. Isn't that
Yeah.
beautiful? It
Right.
feels like, it's kind of sticking hammer and nails where we see holes and patching things.
Yeah.
Don't think
Yeah, I
it's
think to
worthwhile.
me, if we would like if this was the solution, it would solve a lot of problems, like even problems we didn't try to solve, like distorted objects. like recognizing distorted objects, but I agree the solution still seems a bit too complex for it, and especially too complex to be implemented in grid cells or cortical columns.
Neurons.
So,
Yeah.
Yeah.
So,
but yeah, I thought it was useful to just kind of zoom out a bit and
right.
think about distorted objects in general, because behaviors seem to be kind of related to it. So maybe there's a general mechanism we can use for both. But
Yeah, I agree with all that. I think we need to zoom out a little bit further. I have trouble relating this particular problem and understanding it in the broader context of all of our problems. Like just like I was talking about, it's not clear to me one is an object distorted, one is just another object. You know, and then Scott, you brought up the issue of like, oh, the state really has two things. There's like a behavior that when we interact with it, but it could have a behavior on its own. And those are kind of separate things. We're kind of mixing these things together in a way that feels like makes me feel confused. Like, I don't think we got it quite right.
Yeah. Well, I'm gonna try to like because I'm still also trying to understand the problem. I'm gonna try to share the brainstorming Excalibur. So is it sharing? No,
Is this
no,
the
it
one
should be
from
sharing.
the one
From the
Yeah.
brainstorming week.
right?
Yeah.
I looked at that.
So yeah,
But Vivian, you took a lot out of that one and stuck it in a new one, right? So
yeah.
yeah.
Yeah, so this is a different Excalibur. The link is also still on Slack. There's two links for Excalibur. It's the second one. But so the object distortion, I think like the most direct question that it was trying to answer was this: if we have behavior model and initial morphology model, what features should we expect in the morphology model after the behavior is finished? And like implementation wise, like in software, like we can implement this distortion map or um like Campbell replay. I think both are doable in software. um and then but I think like the question that maybe we were trying to get at that is more difficult is this one. Can we use this independent of the object it was learned and apply to another object? Like this is taken a little bit out of context, but basically if we have seen something change from cylindrical to conical in a mug and we see another object, like a completely different, I don't know, object that goes from that is in, let's say, cylindrical form but goes conical, then can we predict the features of that new object that goes conical? Like basically, how do we generalize
Yeah.
I guess that's how do we generalize behaviors without having to kind of learn it again? And I'm not sure if we can. I guess that's my
But-
current position right now. Or, yeah.
So yeah, so this scale map I drew there, that'll be independent of behaviors. It would just be a distortion, but the general question is valid that like I was wondering if we can apply these distortions to new objects if we have learned them on one object, then apply them to another, same way as we can learn behaviors on one object and then apply them to another. So I think both the question that you stated down there was the question that I started out with, like
Right.
how do we take a behavior model and an initial morphology model, go through the behavior sequence, and then make predictions about morphology?
Right.
And in particular, how does that work if there was an object distortion in the behavior? And yeah, that's a nice summary of like, we talked about hippocampal replay, using that for it, and this proposal, like the distortion maps, which both doable in software, both might be difficult to do in biology. And then, yeah, this kind of scale map to me is, like you mentioned, taking it a step further in the sense that this now talks about a separate problem. Like this doesn't solve the initial question that we set out with anymore. This kind of extrapolates and says that we can also use this for like static object distortions where like there no behavior happened, but now we see a bent mug and we can still recognize it.
You know,
Yeah,
this-
that would be
Yeah.
I'm not following all this, but I'm going to try to play back some of it just because it seems like you had this idea back in the research, the offsite we had, Vivian, of like, oh, we can apply these. Well, then let me start over again. Figure out what I just said. The idea here is that on a location basis, we can apply scale, we can apply orientation, and in a hierarchical fashion. And that seems really good, right? And that could explain some of these scale things, right? Like the skinny cup versus the non-skinny cup, something like that. I think that idea really is a good idea. Like we can do this on a point, and getting back to Scott's concern about the models being too big, we don't have to store every point because the system has to extrapolate in between points. So, but it feels like this basic general mechanism on, at certain points, we memorize, oh, for the current scenario, we have some sort of orientation and scale change. I think that's what we're talking about. Was that what we were just talking about? Okay.
Yeah, and then I guess just this question that is underneath that map is like we discussed this mechanism already, like learning things on location by location basis for like a specific child parent object relationship, but
Yeah,
scale is
Yeah.
pretty general. So I was wondering
right.
if
So,
we use that
I agree.
scale
So to me,
generally.
the specific object ID that's passed from layer 4 to layer 3, it's always optional, right? It was optional in our morphology. You don't need it for the morphology model. So I think that's always optional. So just like we have a morphology model, which is not specific to IDs, feature IDs, I think these features too can be, the orientation scale can be not specific to particular child object IDs. And the system should work. It's just extending that idea. So I don't know why that, I'm not sure what why that doesn't work in all these scenarios. It seems like it somehow should work in all these scenarios. And it's not too much of a learning problem because we don't have to store every point. We only have to store enough to extrapolate between them. So I'm sorry I wasn't following everything you were saying, Hojae, but that seems like the essence of how we're going to solve a lot of problems. And I'm not sure where, it's not clear to me now where it fails. So maybe I need to think
okay.
about it more, but maybe Vivian can, or somebody can explain to me what am I missing?
I'll give an example. Where's is there like a stapler picture? Okay, there we go.
Yeah,
Coming,
Scott's flow stapler.
yeah. So let's say like we learn this opening. If I see a laptop, how do I apply this opening to the laptop? I guess that's
All right, well, that's a behavioral model now, right? So I thought we had that pretty well worked out. We have the idea that the behavioral model itself, how we've described it, I'm still with that. I don't mind having two models, one for morphology and one for behavior makes a lot of sense. And I think we can make that work. But the behavior model is independent of a specific, it's independent of any specific object IDs.
yeah,
Right? So
yeah,
just sort of starting basis, our behavioral model should work with multiple things because it doesn't really care about what object is. And we spend a lot of time trying to predict what a specific novel situation, what you'd predict. And I thought we had worked that out. I thought that was, I have to go back and think about
Okay.
it.
Well, if we did, then I don't recall. I guess for example, it's this like the stapler model, like just we have to somehow map, say this is a close position. We have to
Yes,
somehow map
okay.
this to like this position of the laptop and this to like another like towards the end of the laptop. And this is a location basis for the stapler. So how do we kind of,
Well, I
stretch
think
it out
that's
for a
just
laptop, which
that's
is
just
bigger?
okay. Well, that's a separate question about scale.
Mhm.
We're going to run out of time here soon. Here's a parting thought, maybe to think about. We started out even before the Thousand Brains project was going on. When we first came up with the idea of using reference frames, we didn't understand the importance of orientation. We just started putting features at locations. And it was always about what features at this location, what features at that location. Maybe the way to think about this is that the actual features of IDs are secondary to everything. That maybe the entire system can be understood by modeling morphology and orientation changes and scale changes independent of actual specific features. So our models of static objects, our models of behavior, all can be understood as things that are not tied to specific IDs, specific feature IDs. Often in the world, we don't see color if it's dark. We don't, we can do this different modalities. It's sort of like maybe the world is really structured as, edges and orientations and movements of edges and orientations and scale. And as an afterthought, we can apply specific IDs to things. That helps us out a lot. Then we can recognize specific objects, specific flavors of these things. So up to now, I've always started with the specific objects, and we're adding these more generic features to them. Maybe the way to think about the whole thing is to start with the generic features. Just understand, how do we understand behaviors in morphology independent of specific features, and then say, how do we apply that to specific features afterwards? That's like a mind shift a little bit. And we're kind of doing that anyway, I think, but I don't think I've never stated that. I've never recognized that. I don't think anyone ever said that's what we're doing. Does that make sense to anybody at all? Does that sound
Yeah, I
like
think
rambling?
that's I'm gonna
Yeah.
think more about that, and if that can solve some of our additional problems. I guess the first thing that comes to mind is that we still somehow want to be able to make predictions about features. Like if I apply a behavior to a stapler, I'll be able to predict its color, or the color I'm going to sense at different locations correctly.
Right.
Yeah.
We still have to do that, right? We're not ignoring feature IDs. We're just saying the base model is independent of feature IDs. Just like we said, the base model of a face is independent of specific feature IDs, because I can see a face using fruit, right? I can see a face drawn of dots. I can see a face, made of anything, because it's orientations and positions and scale and things like that. So, but in the end, face, the noses and ears and eyes really do matter. And but we can add that later. And that's why it's just a flipping of priorities. It's like saying, let's solve all the, I'm gonna think about this, like how to solve all the problems we've talked about as a sort of abstract, platonic, not platonic, that's the wrong word, but abstract ideas of morphology and changing morphology, and everything. We've already added that we've already done that for behaviors. We've added the morphology model, and maybe I'll just start thinking about everything in that regard and make sure we can solve everything using that mindset. Then we come back later and say, okay, how do I predict what the actual feature I'm going to see? How do I make predictions? When I can make predictions, I can't always make predictions, but when I can make predictions, what would it be?
Yeah. I guess just to add a bit more to this stapler and laptop example, and like how to frame the open question, at least how it is in my mind. I thought we already have a full solution for the stapler and the laptop and making predictions about it.
I thought we did too.
The last missing piece was applying the movement vector to the child object's reference frame, and that solved everything, applying the behavior and recognizing it on a new object and making predictions on the new object. To me, the main missing piece was how that mechanism works on an object that's distorting, with the stapler, we don't have that problem because
Yeah.
the whole child object, the whole top piece moves together and we can just change its location and orientation. But with like something like the balloon, we can't do that. So that, in my mind, was the main remaining open question.
So, but then you slid in, you were spent a lot of time today talking about, oh, how does the logo distort as the object's distorting? And,
Yeah, yeah, I
all
guess
right.
I did. I thought
Right.
that's like might be related, just generally object
all right,
distortion.
but the change in attitude I'm suggesting right now is, don't worry about that yet,
Yeah.
right? Just not worry about it. In fact, I even pushed back a bit, like, can I really make a prediction about that? I'm not sure I can really make a prediction what that thing's gonna look like as it's distorting.
Yeah, I mean, I think it's still, even if we don't make predictions about features, we still need to be able to deal with distortions in morphology.
Right, right. I agree with that. And to me, that brings up the egg circle problem.
Yeah.
And all your cup examples and so on. Look, what I'm proposing here is not a solution. It's just, it's maybe a little bit of a mindset. It's like saying, okay, let's deal with the balloon problem, but let's not worry about how I'm going to predict what the logo looks like. Maybe I need to predict the distortion of the surface in general.
Right.
Yeah. I think the
And-
reason they brought in the logo is because in some past meetings, an argument for the balloon was that you could just solve it with rough scale, and or like generally like putting the logo on the balloon makes it easier to show the issue that you can generalize that deformation to new objects, like you can apply the same deformation to the logo or to any new logo. And that's why I brought it in to
Okay.
show like this
Well,
generalized
fine.
rule,
It was a good
um,
exercise, but now I'm arguing that now that we've gone through that, I think I don't want to go through that right now. I want to go
okay,
back.
yeah, I think if we all agree that like these properties need to be solved, then yeah, I think it would be much easier not to think
I mean,
about the
to
logo.
me, the balloon is a more weirder case of the egg and the oval. It's
Yeah.
like it's a more extreme case. Right. Like I think it's a great exercise. We did everything we talked about today. It was great. But doesn't mean if today's exercise means it gives us some time to think about these problems slightly differently, then maybe that's good.
Yeah, definitely gonna go away and think some more.
Right. It's just a weird thing now to think like, oh, this idea of reframing all these problems is just sort of morphology problems in a broad sense, is very liberating in some ways.
So maybe next week we can talk about eggs and ovals.
Yeah, right.
I was gonna say that, yeah.
I was just, and yesterday I was trying to write a little write-up about the nature of the world and the structure in the world. And try to really get down to the base of like what is actually going on in the world. What does the world consist of and how we're modeling it. And this idea is really interesting, helpful to me to think about like, okay, let's think about the world in terms of its basic morphology and changes in morphology. Because so much of the world is like that. So much of the things we see are like that. And then these specific details, like even things like color, are not persistent, right? A green isn't always green. And so I can't say if it's this color, it's a green apple, because in different real scenarios, it isn't. But the shape is always the same. I'm just thinking out loud. So, to keep everyone. I think it's a liberating way of thinking about it.
Okay, so maybe we can try to think about behaviors again, but without any features per location, but just in terms of, I guess, think of it as a black and white world with just edges and morphology.
Right. I think we had as Vivian just said, Hojae, we had a pretty good solution for behaviors.
Yeah.
I think the challenge that Vivian's bringing up is, I think, the one of distortions. And I don't even think we have a good definition of distortions. because I was arguing earlier, but so I think what we really want to be able to do is like, let's just think about the entire collection of things we've come up with for the Thousand Brains project. Thinking of us first starting up this morphology based view of the world, and then how do we and solve things like distortions and behaviors and so on, which many of which we solved already, and then ask how do we fold back in specific behavioral IDs as we go. So I think we got behaviors pretty well, pretty close.
Yeah, actually,
So-
maybe it was too much to bring into distorting behaviors when we don't even have a solution for distorted static objects. It might actually be like a separate problem. So yeah,
Yeah.
I
yes.
think one area that I'm particularly interested in here with this behavior model is the distinction between the cumulative version and like the totally differential version.
Well, I'm not a fan of the cumulative version. Right.
Yeah.
So we didn't, that was a new idea that Vivian brought up. So
I think it came up last week as well. Like I'm also a fan of the differential version. It makes more sense to me in terms of like how you'd learn it. And it doesn't require necessarily having like a starting, like a supervised starting point. Now we go kind of thing. I like the idea of and it also seems to comport with like, if you asked me to sing a melody, I couldn't just start it anywhere. If you asked me to start halfway through, I'd probably have to go back to the beginning, and then So I think I like the idea of these differential models. So I don't know, maybe that's like an area that would be rich for future discussion and
When you
I
say
think maybe-
differential models, do you mean like how we've been talking about behaviors so far, like changes
step by step.
yeah, step-by-step application, having to basically integrate through the whole model and
Yeah, so I'm also a big fan of that. I don't want anyone to think that I'm saying we should not do that anymore. Like, this is definitely still how I'm thinking. We are learning behaviors and recognizing behaviors, and in my mind, that's totally independent of the distortion maps, which
Yeah.
are
And then it's
don't
something on
have
top.
a component at all. They wouldn't replace a behavior model.
Gotcha.
They would just be there to be able to kind of remap locations in the morphology model to predict the correct features as it is distorting.
Okay.
Yeah.
What would be helpful for me or in general next week is if we can kind of end with either a question that we can think about for next week, if we can kind of come up, or if we cannot really like say that concretely now, to at least post on Slack relatively, like not to say, I guess, earlier, so that we can kind of get a chance to think about it. Yeah.
I think I'm gonna think some more about the egg and oval example to just focus on morphology and
Okay.
see if that can, if
Yeah.
there's a simple solution to this kind of distortion.
But I think, the whole idea of distortion is both unanswered, but poorly defined.
Yeah.
Right.
So I guess my question is, what about the egg and oval? Like what?
Well, the egg and
Like, when does
oval,
it
the
become-
balloon, the bending coffee cup, the t-shirt, these are all variations of distortion. And I don't think we have a crisp definition of when something's distorted and when something isn't distorted. The
okay.
the flavors of it. So I think the problem that Vivian's been working on is still a good problem. I just don't think we have a clear clarity of what the problem is. We have some examples, but it's confusing if they're all the same, or if they're different, or they're on a scale. I don't know. So
Yes,
if
yeah. If I had to define it, in my mind, it's defined as the same feature now appears at different locations and orientations in the object's reference frame.
Okay, if we're just thinking about morphology models, then they can forget about features. We could say that there are changes in orientation at different points in the reference frame and locations.
But
Okay,
at
right.
least, yeah, the object, parts of the object will now exist at different locations and
Right,
orientations.
but that also applies to behaviors, right? I could say behaviors do the same thing.
Yeah.
right? And I think that we're talking about deformations as something different behavior or flavor or something different than behaviors. So I don't think
Yeah.
that's a good enough definition yet. Maybe it is. I don't know. I need a definition which clarifies all these things and says, oh yeah, here's how they're all related. This is A and B and C. These are all, they all fit into some scheme. Um,
Okay.
I think, you know,
Maybe
Hojae, we could say, we need to spend more time thinking about deformations. We need a better
Yes.
I think Vivian just threw out a proposal definition. I'm gonna see if I can improve upon that. Other people can do that too. We can come up with more examples of deformations so we can have more of a spectrum of things. Maybe we're missing some good examples that would help us clarify things. To me, that would be the most important thing, is to have a better definition of what are the set of problems that deformations relate to. And behaviors could be in that spectrum, right? Behaviors could be deformations that occur over time versus deformations that don't occur over time. I don't know.
Okay. All right. That clarifies at least kind of for me what to focus on for the week.
As much as we can.
Yes.
Sometimes it's really hard to do this.
All right.
Are we done?
Yeah, I think we had a good point.